So here in this problem, we are given three circles. The equations are given to us. We need to show that the centers of these three circles are collinear. Meaning, if we draw a straight line, then the center of the circles must lie on the line. So let's try to show that. So we'll begin this problem by using the general equation of a circle, or the general form of a circle. This is given by this particular equation: x squared plus y squared plus 2gx plus 2fy plus c equals to 0. So here the constant g, f and c can be used to determine the center as well as the radius of the circle. Since in our case we only need to find out the center, but that means we need to find out the value of g and f. So let's begin with the first circle. So we have x squared plus y squared minus 4x minus 6y minus 12 equals to 0. So if we compare this with our general equation, then we get 2g equals to negative 4 and we get 2f equals to negative 6. So g comes out to be equals to negative 2 and f comes out to be negative 3. Now the center, let's denote it by c1. So since the center is given by negative g, so positive g is negative 2, negative g will become positive 2. Similarly, negative f will be 3. So we have obtained the center of the circle. Now we're going to label this as number 1. Coming to the next one, we have x squared plus y squared plus 2x plus 4y minus 10 equals to 0. So here we get 2g equals to 2 and 2f equals to 4. So g comes out as 1 and f comes out as 2. So the center denoted by C2 is going to have the coordinate negative 1 comma negative 2. Let this be number 2. And coming to the third equation, we have x squared plus y squared minus 10x minus 16y minus 1 equals to 0. So its center must be equals to 5 comma 8. So let this be number 3. So now we have the coordinate of the center of each of the three circles. Now in order to show that they are collinear, so let's try to find out the distance C1, C2. Distance between the two center C1 and C2. For this, all we have to use is the distance formula. So we'll take the square root, and underneath the square root, we'll have to first take the difference of the x coordinate. So we'll take 2 minus of negative 1. So that's 3, and then square it. Then we're going to take and add this to the difference of the y coordinate, which is 3 minus minus 2, that is 5, and we're going to square it as well. So that's going to give us square root of, so 5 squared is 25, 3 squared is 9, 25 plus 9 is going to be 34. So we get square root of 34. Then let's try to find out the value C2, C3. That means distance between the center C2 and C3. Same by using distance formula. So the difference of the coordinate will be negative 1, negative 5, so that's 6 squared, so that will be 36, plus we have negative 2 minus 8, so that's negative 10, so that's the difference of the y coordinate. Squaring it gives us 100. So we're going to get square root of 136. So this becomes equals to 2 times square root of 34. Fine. Now since we're getting C2, C3, that's exactly equals to 2 times distance between C1, C2. Hence we can say that C1, C2, C3, the center of the three circles, are collinear.